Okay, the last example for this section is example 6. And it says, Hillary is the coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on calm days and a 70% chance on winning on windy days. Tomorrow, there's a 40% chance of high wins. There are no ties in ultimate. What is the probability that Hillary's team will win tomorrow? So this is a case where there are a couple of different things you need to look at. First, there is the probability of winning, right, in general. And then there's the probability of what the weather will be. So there are basically two cases here, right? It's the case that the weather is calm and they win. And there's the case of the weather is windy and they win. So the probability of a win depends on two different things: the probability of the weather and the probability of winning in general, right? So we have probability of weather and the probability of winning. So your notes here start with these arrows, because it is helpful in these situations to build a tree of events or outcomes, right? And you'll see what I mean here now, because we'll put some numbers to this. So one outcome will be calm weather, the other outcome will be windy, and we'll put some probabilities on those. So it's a 60% chance of windy, high winds, so that means there's a 40% chance of it being calm. And I'm going to switch these to decimals because it'll help for multiplying things together. So if it's calm weather, we have two more outcomes: a win and a loss. So the problem gives us that they have a 60% chance of winning on calm days, which means there's a 40% chance of losing. And for windy days, we also have a win and a loss. And then it says there is a 70% chance of winning, which means a 30% chance of losing. So these little event trees or probability trees can be very helpful once, if you're dealing with a problem that has a lot of dependent events or interlocking dependent events. So winning depends on weather, we're saying here. Winning depends on weather, or at least the probability does. So that makes these dependent events. So let's calculate it, our probability of winning. So like I said earlier, there's two cases. The first is that we have calm and win. And our case 2 is windy and a win. So we have the probability that it's calm. We'll go calm times the calm win. So I'll do a capital C win. And that's going to be plus the case where it is windy. And a windy win. So that's all. I'll distinguish those. So we get 0.6% that it's, or 0.6 that it's calm times 0.6 of a win in calm weather, and then it is a 40% chance that it's going to be windy times 70% that they win in windy weather. So this will give us 0.36 plus 0.28, which is 0.64. So put equal signs in. Which equals 64%. So overall, good chances of winning. Sounds like they're a good team anyways. So there you go. This is a good example of using these event trees, and you can expect to see problems like this moving forward.